Hi, I'm Mike Mulligan. I live 2 miles from Vermont Yankee. It's a very similar plant to Pilgrim. I'm a whistleblower and a nuclear safety advocate. I worked at Vermont Yankee for 13 years. I was a licensed operator and I rode nuclear fast attack submarines for 4 years. So we're going to talk about the Pilgrim's most recent inspection report and an issue that Pilgrim got into trouble with. I don't know if it's 2011 or 2012, where they mismanaged reactivity up in the control room. They were in a startup and it was just horrible. They were playing musical chairs, jumping in and out of the control room, during this evolution. The whole bunch of them, especially the senior managers, were excusing themselves and going out to lunch or doing something else during the startup, and the employees and some of the employees did similar. It's like everybody kind of just didn't want to do the startup. They knew they were going to get in trouble, and everybody was trying to minimize their risk of getting caught during the evolution. It just looks like a bunch of nervous guys saying to themselves, "I got to get out of here before we screw up." But anyways, that's an insider thing. Nuclear safety, the idea that they would be doing that, jumping in and out, leaving the control room in the middle of this kind of a startup evolution, one of the most complicated, and you got to really have your eyes there, and you got to be there. It's one thing to be there and an event occurs, or a series of events occurs, or you're in a startup, and then there's another thing to come in cold and somebody telling you all these things happen. It's not, you don't have all the details as you do with the as you would, if you were in there and stuff like that. So they botched the startup, they scrammed, and it looked horrible. It was, as far as nuclear professionalism and a whole ball of wax, it was horrible. It's just utterly amazing something like that could be going on in a nuclear reactor control room and stuff. It's just mind-boggling. So anyways, let's go look at that assessment follow-up. It just came out December 13th, 2012. And on November 15th, 2012, the U.S. Nuclear Regulatory Commission completed a supplemental inspection pursuant to inspection report inspection for one or more white inputs into the strategic performance area at your nuclear power station. Involved the failure of Pilgrim Nuclear Power Station personnel to carry out their assigned roles and responsibilities and to adequately implement conduct of operations and reactivity control standards and procedures during a reactor startup on May 10th, 2011, which resulted in a reactor scram. They're going to talk about Pilgrim's root cause analysis. However, most of the inspection objectives were met. However, some observations regarding the root cause and extent and quality of energy's corrective actions were noted. There were weakness, but nothing ever matters. Agency, they could have fuel and melted down fuel in the control room, and it wouldn't be, it'd be nothing ever matters, as far as I'm concerned. So I hope I got these shaded so I don't delay. Energy identified the root cause of the issue as the root cause of the event was failure to adhere to established standards and expectations due to a lack of consistent supervisory and management enforcement. Establish standards, you know, it's crazy. Adhere to established standards and expectations, but then, and supervisory and management enforcement. So the managers weren't following their own established standards and expectations. You know, I don't know. Did anybody get fired from this, or was this just doesn't matter? The NRC concluded the root cause evaluation was thorough and appeared to identify the underlying causal factors. And you'll see, you'll talk about, with this failure to adhere to established standards and expectations due to a lack of consistent supervisory and management enforcement. You tell me, on this SRV business, with the brand new valves and 3 failures, and they couldn't prevent that failure from happening, the leakage and twice shut down. You tell me that this established standards and expectations due to a lack of consistent supervisory and management enforcement. You tell me that's not involved in that in the SRV business. It's ridiculous. And also the shutdown during the blizzard. A blizzard, right? They're having a big old blizzard going on there. Expectations of troubles on the grid, a transmission system, historic blizzard, and probably a high probability they were going to scram. They all knew that and stuff like that. And then they had this component that's critical to keeping the core cool. They bought a new valve and it failed 3 times and stuff like that. Critical for loss of off-site power business as far as risk. And stuff, a component failing during a loop or a station blackout, potential station blackout, and here they are with these bad SRV valves. One was causing them to be at 80% power. If they went up higher, it was going to leak again. Nobody had an idea what was causing that leak. And stuff, and so they went into, and then they were going to face this blizzard where they knew they were going to have troubles with the transmission system, and these guys weren't smart enough to figure out the safest and most conservative thing is to shut down instead of taking a scram. How is this conservative? How is this in the interest of corporate energy and all that sort of stuff? But I don't work there. Never did. The finding was associated with the failure of Pilgrim personnel, including licensed reactor operators and seasoned licensed reactor operators, and the shift supervisor. Where's the shift? Yeah, the shift supervisor, the big dog inside there. Conduct operations, reactivity control standards and procedures during a reactor startup, which contributed to an unrecognized subcriticality followed by an unrecognized return to criticality and subsequent reactor scram. This is the stuff that you just never think what would happen in a reactor control room in the United States. Although it's happened a few times and stuff like this, to this idea that a reactor would become subcritical, and all of a sudden somebody would do something stupid and it would magically become critical, and then the power would scream into the trip. The idea that would be one of the worst accidents. Have an accident when you're really low in power, and a lot of your rods are pulled out of the core, and you have xenon in there and all that sort of stuff, decaying away, increasing reactivity. The whole thing of xenon and all the different poisons in there going on around there, and stuff. It's just unbelievable that they could be so disconnected from watching their gauges and operating safely. So anyways, we go into that. The inspectors noted while energy's root cause evaluation did not explicitly identify who identified the issue, it does provide sufficient detail on how the issue developed to determine that the issue was self-revealing. They tripped the reactor and stuff like that. Our whole thing would be interesting. You know, how did the NRC get to see the underlying things here? Did management go to the NRC and spill the beans, or did the NRC go around there and started asking questions and getting deeper and deeper, and then Energy spilled the beans? You know, did Energy kind of just was hoping for that would blow over unless the NRC asked the right questions? So self-revealing findings, you know, and violations are those developed from issues that become self-evident and require no active and deliberate observation by the licensee. The NRC inspectors determine whether a change in process or equipment capability or function has occurred. Self-revealing. So if it wasn't self-revealing, you know, what is it? You had a secret scram. You know what they're saying is that they had that if somebody else discovered it, I guess that's what it comes down to. Not somebody, not the Energy, but the NRC or somebody else. Energy did not explicitly state how long the issue leading to this event existed. The root cause evaluation documented a review of internal and operating experience. The internal review identified numerous instances of failure to adhere to standards and expectations or to follow procedures, none of which resulted none of them which resulted in a reactivity mismanagement. And like I've been telling you, you know, as far as standards, expectations, and following procedures, it's still going on. And so, like I'm saying, you know, where is it? Where is it that something whacks them on the side of the head, or the NRC whacks them on the side of the head, and they finally say, you know, enough is enough, and we're going to change our tune so these things never happen again. You know, where is that? Instead of, you know, well, we're going to go through another silly NRC process, and we're going to dance around with the, you know, inspection findings and responses and stuff, and we're going to please the NRC in filling out our paperwork, and we're going to be contrite and apologetic and stuff like that. But, you know, but nothing ever really changes. You know, a month goes by and they're back to the same old crap, doing things over and over again. And you know, well, some of this stuff is big stuff like this, but a lot of it's, you know, is minor problems, but at a significant level. And people say, you know, well, it's a minor level. Nothing's, you know, it's not a big deal, and it's a risk to no one. But minor problems, they have captured in them all the behaviors that it's going to happen with big problems and stuff. Minor problems are extraordinary as far as the information they carry. You know, a lot of bad behaviors, and you get to see what the organization does and behaves in the background and stuff like that, and you can predict how they're going to behave in the future and stuff like that. So minor problems are, I don't know, you know, minor problems. Can you have a big problem without it emerging from a minor problem? You know what I'm saying? Or an insignificant problem? Does all of a sudden, bang, it shows up as a major problem without it showing up as a insignificant or minor problem? You see what I'm saying? The agencies is well, it's corporate pay, you know, campaign contributions and stuff like that. They want to give everybody, you know, the vast majority of the problems are minor problems, and it's something that you need not report to the people and stuff like that. That's why this is going on here and stuff like that. You know, anybody that knows anything about problems and institutional problems will tell you that the gold mine, the diamond mine, is in the minor problems, and paying attention and knowing that a song is being sung to you when there's little problems going on at the plant, and bungling little problems and stuff. You can see a lot of how you can make a model of how the organization is behaving, and if you're astute enough, you can start changing behaviors. You can force the change of behaviors, but you know, that's not the system we're in now. It's just nothing ever matters. You know, risk inspection means nothing ever matters. And stuff. So, you know, like this is really not. You never challenged a
fuel barrier and stuff like that. So it really didn't matter. It's insignificant. We had to fill out a lot of burdensome paper, and the agency had to spend a lot of resources on writing these inspection reports and bringing in the inspectors, and stuff like that. Thousands of dollars and all that sort of stuff. But did they change anything? Really, fundamentally, did they change the behavior of energy? And the thing is that maybe they ain't going to get into a reactivity incident again. Maybe during a startup, everybody's going to be paying attention, and there's going to be no lunch breaks or piss breaks during a reactivity manipulation. But as far as the types of behaviors that cause this, they're still in other areas, and that's the trouble. They're still in other areas. They're still in 99.9% of the organization's issues and problems and stuff like that. They might have cleared out 0.1%. Never again they're going to have a reactivity problem in the control room as they did talking about this guy here. But all the behaviors that cause that are still spinning around and causing more problems throughout the plant and throughout the energy organizations. And energy over the years, Palisades, and they've all had ADR processes, process where instead of getting violated, the agencies allows a company like Energy to go into a voluntary process, and a lot of stuff gets hidden underneath it and stuff. Of problems. It's a good way to hide your problems, the ADR process, as far as if you're a utility, and you can drag it out for a couple of years, and then you can make believe that nothing ever matters and all that sort of stuff. And so a lot of problems with Energy, their employees watching TV while they were in the control room, intimidating a QA inspector down south. I don't know if it was at Grand Gulf or I think it was at Grand Gulf and stuff like that, and a QA inspector, and having QA inspectors with the wrong credentials and all that sort of stuff. And I forgot what I was saying on that guy. But anyways, so, inability to carry out, the licensee stated that ineffective adherence to standards and expectations and inability to carry out fundamental behaviors during reactivity manipulation represents a serious challenge to safe operations. Oh yeah, now I know where I was going with that guy. So, over the years, all these big events, the employee watching TV on shift, or the internet while he's in the control room, they intimidating QA inspectors, they not having QA inspectors with the right credentials, they having refueling rack issues. Their racks were all swelling on them, and causing troubles in the fuel pool, and they ignored it for years, and they got ADR. They went through ADR on this and stuff, and out of all of these things, they get. I swear, no other utility in the United States has had fleet-wide safety culture training as much as Energy has over the years of these big issues that caused them to. ADR process caused them to do a safety evaluation, site-specific and culturally within all of Energy. And like I say, it doesn't change nothing. They get to turn in their paperwork. It's checked off as being complete. And stuff to the NRC, but it doesn't change behavior. It's crazy. It's crazy. There's no expectations that, the ROP, is it effective? Is it causing Energy to change their behavior type of thing? There's no thinking like that. And then what do we have to change in ourselves, in the agency, in order to make Energy behave and stuff? There's just an acceptance of this craziness that's going on in the industry that is it is beyond imagining, and it keeps it keeps saying this over and over again. The root cause of this event was failure to adhere to established standards and expectations due to a lack of consistent supervisory and management enforcement. You know, they did that at Vermont Yankee with their leak, with their tritium leak and stuff like that. Same basic stuff. And so we go on through this thing. I could give you another rendition of the root cause of this event was the failure to adhere to established standards and expectations due to a lack of consistent supervisory and management enforcement in the control room. But, where contributing causes weakness in monitoring, weakness in just-in-time training, procedural guidance not optimum, weakness in teamwork. We continue to see that same stuff going on and on in the energy plants and at Pilgrim and stuff. They get in trouble, they get dinged a couple of times, and just everybody forgets about it. And then they get to do the same stupid stuff over and over again. And how is this going to end up? How can this end up in a good way? Energy performed a safety culture of evaluation and considered the safety culture aspects of work practices and the continuous learning to be applicable to this issue. Corrective actions have been completely taken into consideration the input of the safety cultural aspects. And like I say, all these issues over and over again that they've had fleet-wide cultural evaluations and testing. And 3 or 4 times, and none of it works. When they're going to get to the problems is this cultural stuff, this way they do cultural evaluations and stuff like that, and kind of asking them what's wrong with it and doing a quick fix that pleases the NRC but doesn't change behavior. When are they going to get into their heads that it's not working and they got to figure out something else? So we're going down some more in this inspection report, and we're done with that guy. Quick and dirty. And now we're going to go into the most recent Palisades. Is there a difference? in the Pilgrim Inspection Report, most current inspection report, January 31st, 2013. This report documents 4 NRC identified findings of very low safety significance, of which 2 were involved violations, 2 of which were determined to involve violations of NRC requirements. Findings of very low safety significance. Let me translate to you what that means. That means there's no necessity for you to change. I mean, all you got to do is respond to our questions and respond to us in paperwork, and you have to respond to us in a nice way. You gotta respect us in front of the public, but there's no need for you to change. So when you see this all the time, non-cited violations or NRC identified findings of very low safety significance, that means there's no need for you to change your behavior. There's nothing wrong with you. Remember I told you, small problems are like finding $100 on the sidewalk. It's a gift. It's a gift given to you from the universe, and as such, you're supposed to look at it very carefully, and check your behaviors up against the evidence you see and stuff. And then again, 4 NRC identified findings. So why can't energy identify these themselves, right? Why can't they identify these themselves? Why do they need the NRC to identify these findings? It's a rotten system. It's a rotten system. It's a rotten system that accepts the status quo, and everybody gets to dance around with the inspection reports and fancy paragraphs of words and stuff like that, and nobody's required to change. That's what the problem of this is. And so we will go to the inspection findings. The inspector identified. We're gonna break here for a second. Pilgrim with their blizzard scram, right? And then their scram, and then their next their loop. And what that means is they were disconnected from the grid, and they were wholly dependent upon their diesel generators. We don't know how their diesel generators worked during that time, and it was a prolonged. This wasn't usually loops are an hour to maybe 4. This guy was a prolonged loop, and again, that's it risks. As far as the NRC looks at this kind of risk-wise, they think it's nothing. I think this is a very intense indication that something is wrong. That you should never tolerate. You should never tolerate. I don't care if it's in a blizzard, hurricane. But a blizzard like this and repetitive in nature and stuff like that. Only 85%, only 80 to 90 mile per hour winds, and it blows a nuclear plant into. Depending upon their diesel generator, there's something wrong with that there, and stuff. And then they had to scram, and then they were in a loop for a while, and they got the loop back. They got power back on. We don't know if it's 1 or 2 lines. It's probably just 1 line, and stuff. And then something tripped their startup transformers. They say ice fell from a line or from one of the resistors or one of the components on either the line or in the connection into the startup transformers, and caused another loop and stuff like that. You remember that? You remember that startup business, and you remember something tripped at ice or something like that. And you tell me when we get done with this, you think that's the same. You think that really is what's going on there, and I'll tell you, there is nothing that the NRC mandates. There's no honesty the NRC mandates with these reportings. They completely let them guys report this as they see fit, and very seldom do they correct them. Correct them. Inspection in LERs and stuff like that. The first swipe can be completely fictional and based not at all on science and engineering, just on what makes them look good. Maybe gets them out of, maybe allows them to operate at power with bad equipment and stuff like that. But no anchorage to the facts in science and engineering. You mark my words, that's what's happening here. These guys can write fiction in LERs, and they can write on the first report, on the reports to the media. There's no compulsion, there's no punishment if they're lying, and nobody holds them to their honor and their word. Mark my words, that's the truth. The inspectors identified a finding of very low safety significance. In other words, no behavior change is necessary. There's no concern. All you gotta do is kind of fill out a couple of couple of check marks on a couple of sheets of paper, and a couple of, yes, the NRC, you're defining this, and stuff like that. But no change in behavior. Involved a non-cited violation of Appendix R corrective action because Energy did not identify an overload condition on the B15 bus after a similar load condition was known to exist on the opposite side B14 bus. Basically they did similar tests. This is a good part of them. We're doing a simulator test of the crew, and they simulated losing the B14 B15 type of thing, and they went through the simulator session, and the NRC said, okay, well, yeah, fine and dandy, you did it in the bowels of a computer, as a computer simulation and stuff like that. But how's that really affect the plan? How's that really affect the plan? Stuff that Energy should have been doing on their own. They should have known that the B15 and B14 could be overloaded, and they should have never out of a simulation examination, discovered that actually the B14 and 15 through the NRC was not right, wrong. And this is, this is part of the loop or station blackout issues. This is dealing with a station loop, or so. A month ago, 2 months ago, whatever, how long ago, they were talking blackout issues and loops, and being terrified of loops and stuff like that, and trying to clean up all the mess that Energy wouldn't clean up about dealing with a loop. So that's the inspectors. This is the second one. Inspectors identified a finding of very low safety significance involving. In other words, this is not a big deal. You need not change nothing. You fill out some paperwork, behave the same way you are, keep your head down, don't look in front of you where you're walking, and everybody will be all right. Because Energy did not implement design control measures commensurate with those applied to the original design when a system modification was made to the emergency diesel generator fuel oil transfer system, right? Loop, and we're talking about loop and feeding the diesel generators probably through their tanks, through their tanks. They had a hose that was that wasn't. See, and the inspectors found it, not Energy. It was a hose that was it didn't meet the specifically. Energy did not implement design change or modification process when a station blackout diesel generator fuel transfer system was put into place in 1998 to meet the EDG support function of transferring sufficient fuel to meet the mission time of the EDG safety function. Mission time, we don't want to spend too much money on the emergency diesel generator, blackout diesel generator, so we make them, we arbitrarily decide a mission time, a day or 10 minutes or maybe a week or whatever it is. That puts the limit on how expensive the system has to be. Not necessarily what you really needed, plus a safety margin. Energy replaced the degraded and non-conforming hose and documented the issue in their corrective action. Right? The performance. The inspection identified this. The inspectors identified a finding of very low safety significance because Energy did not complete a shutdown transformer bus A battery discharge testing with the required time frame as required by procedure, blah blah blah. This but was a potential risk significant due to seismic flooding or severe weather initiating event? Shutdown transfer bus battery discharge testing within the required time. Shutdown transfer bus battery. It must be the control power for the breakers and probably for the battery chargers and all that sort of stuff. Another one. How many? That's the third one. The inspectors identified a finding of very low safety significance because Energy did not verify the adequacy of the design of the station blackout battery as required by. Did I do that one? No, it's the same one. It's another. It's two bangs for a buck. Specifically, Energy used an incorrect minimum voltage for this SBO battery, resulting in the sizing calculation significantly resulting in sizing calculations significantly overstating available design margins. You know, these guys, you watch them and stuff like that a number of years, and you know what? The mistake always goes on saving a buck. You know, you never get them making a incorrect minimum voltage, and it causes them to have a battery system that's twice the needed size of the battery or system. You know, it always allows the innocent mistake always allows them to get a cheaper battery, to purchase a smaller battery, a more inexpensive battery. You know, I just noticed that on that. So, anyways, we're gonna go down. That's the four. You know, and basically plant configuration. They're talking about making sure your designs, your initial designs, the components all support those initial designs. This is stuff, you know, as a 40-year-old plant, and they're still having these problems of sticking to their initial design of the plant and finding problems they should have found 40 years ago. You know, I'm just saying. During the week, right? Stand by SBO batteries and control batteries and SBO station blackout. I mean, can you imagine a station blackout? You know, energy sits. I mean, Pilgrim sits there and they got no off-site power. They lost their. We were almost there at Vermont Yankee, and you have no diesel generators. And you're running around trying to, you know, perform the station blackout procedures. You know, when you get to station blackout procedures, none of these are tested. When I was in the service, when I was in the Navy, everything was tested. You know, you couldn't call something operable or anything. It was, you know, unless you actually did a test on it. You actually aligned the system up like you were going to need it in an accident, and you banged around the system, started huge components up, you know, for a submarine, and you tested the system, and you beat the shit out of the systems by doing training and all that sort of stuff over and over and over again. Half of the wear on a Navy submarine is caused by doing this training stuff. And of course, if you get into an accident out in the sea, and you know, and that's the only thing you can depend upon is your training. You know, your instincts kick in, and you go through your stuff. You know, even though you might have a leak, or you might be in a place you shouldn't have been in, and your instincts kick over, and you know that your systems are going to work. You absolutely, because you beat the shit out of them systems. So you know your systems are going to work. And the station blackout stuff, none of this stuff is tested. You know, they just make assumptions. You know, they might hook up a little different line from the fire pump to the vessel and stuff like that, but nobody ever actually lines the system up to feed the vessel, right? You never know if that line is completely, there's not a clog in it or anything like that, or there's, or there's some protection device you never thought of that's going to trip the pump or something like that, or just so many variables. You know, you just can never go by an engineering calculation or a computer model. This computer model business, San Onofre with their steam generator tubes, there are so many inputs you can fiddle with that you can create an accurate model. I mean, you just can't say, oh, well, God's here, it's the computer model, and that's all we have to depend upon. I mean, really, you just a computer model of a system is good, but if you're overly dependent upon it, it makes a problem very bad. You know, it allows you to install bad steam generators when you shouldn't have, and make a fool out of yourself later on, stuff like that. So computer models they are invaluable, But on the other side, as invaluable they are, the errors that they can make is just as bad. They give you an opportunity of seeing something you can't see normally, a computer model. On the other side of it, if you do it the wrong way, the potential of an error is just as bad as how good it is, what good things it brings to it. You have to be very careful. Like science and technology is wonderful stuff, but in the hands of the wrong person, science and technology and engineering, depending upon where their heart is, can can leverage good or leverage bad, and stuff. And you got to be very careful with this kind of stuff as far as how you use it, right? Science gives you an advantage, but it doesn't say if you're good or bad. It doesn't say if you're going to use it towards the good or to the bad. You have to morality and ethics and transparency. Don't forget transparency. Okay, so we're going down. So I'm looking down here, maintenance risk assessment and emergent work control, and it says the inspector also reviewed the tech specs and inspected proportion of redundant systems when applicable to verify risk analysis and assumptions were valid and applicable requirements were met. And so then you see down Sandy's coming and they're checking their 120 volt electrical bus being in its backup power supply. They're worrying about why isn't it, and then that thing here, like emergent yellow risk assessment following unexpected loss of the B emergency diesel generator control power. They lost the ability, unexpected loss of the B emergency diesel generator DC power, and we're talking about a blizzard, Sandy, loss of all off-site power, and we're trying to imagine a world where you're running around testing a station blackout procedure for the first time, really. And stuff like that, and you don't think you're going to get the nation's attention if you end up doing that? I'm telling you, it'll be a big concern and stuff. So they lost unexpected loss of the B emergency diesel generator control power. In other words, an inability to use the B emergency diesel generator power. So. And here the NRC is, operability and determinations and functionality assessments. At least the NRC is worrying about loops and station blackouts. You got to give them credit. At least they're worrying about it. How effective they are, I would say they're not very effective at changing behavior. They got their paperwork filled out. They protected themselves if a station blackout error happened. But as far as getting energy to do the right thing, they're not close there yet. So the inspectors reviewed operability determinations for the following degraded or non-conforming conditions. Arcing sound emanating from the startup transformers, breakers. Arcing sound emanating from startup transformer breakers. Startup. Remember I told you in the blizzard, when they were shut down, and they recovered one line, and then they had energy says ice fell down and caused a short, causing the startup transformers to break, right? 2 years earlier they had another storm, and ice fell down and caused a short on the main transformer and caused a lot of troubles and stuff like that. But anyways, so this, I wonder, I always wonder if, they just, have to have a reason. We tripped, but we don't know what caused the trip. We'll just say it's ice. And and maybe it's the transformer breakers were broken or shorted or something like that. See, we don't know. Pilgrim gets to, on the first take after an incident or accident, they get to say whatever they want, and it can be totally inaccurate and stuff. And so here, we don't know when this transformer breaker, the arcing sounds was going bad on that. You know, what they were using, why they were using that breaker and stuff like that, and was the startup breaker problem in the blizzard, the recovery from the blizzard, was the real reason was because the transformer breakers were arcing? Did they fix that? Did they fix that when they heard that arcing sound? Or did they brush it off and saying, oh, well, that's expected, and the NRC will just ding us on us if it later breaks and stuff. And so so you just don't, you really don't. I mean, to see that arcing was going on in the startup transformer breakers is disconcerting, and it's a safety issue. And everybody's not taking care of the equipment right. And you don't know how many times was there arcing in the past. Did they do a full inspection? Did they rip that breaker apart, or did they say, "Oh, we got to start up fast. We got to have that guy back in, and we don't have time to do it. We'll wait until the shutdown." You just don't know. And another interesting thing with this risk stuff: leakage from the first point feed water heater. Leakage from the first point feed water heater. Leaking valves, leaking pipes and stuff like that. This is from the feed water heater. It's high energy steam. Usually it's isolated from the employees, but if you don't know where it's coming from, if you have one of them big pipes that you don't know if it's on the steam side or it's on the water side, and if it's a feed water heater and it's on the water side, there's a lot of energy in that 580 degree water that turns into steam. You don't know the nature of it. And reactor core isolation cooling valve leak, and that kind of says, well, why all these leaks? Why all these leaks? Why is Palisades shutting down for all these leaks? Why are these plants tolerating so many leaks and stuff like that? Why are they tolerating so many problems in their electrical system and stuff like that? They document it, they fix it one at a time, but are they seeing the big picture? Are they just accepting one component failing after another, and nobody's taking the big picture? And well, we got a strategy to stop all those kind of shorts and leaks. And what is the nature of all these leaks? Is it 40-year-old plant? Are we going to deal with these things one at a time? You never know when you're dealing at one at a time. It's easy to get overwhelmed. So back to that B15, because Energy did not identify an overload condition on the B15 bus after a similar overloaded condition was known to exist on the opposite B14 bus. Somebody after that simulator exam said, we're going to figure out exactly what's going on with the B14 and B15. Actually, almost like well, they caught us on the B14 and don't say nothing. The B15 we know is going to overload, but maybe we'll sneak away from it and the NRC won't catch it. But the NRC, forces their hand. So corrective actions were taken to immediately reduce the existing loading on bus 14. So what bus? Why is that overloaded? How come the breakers and cables are sufficient enough that they don't have to worry about it being overloaded? And again, on May 24th, the MRFF determination was completed and included that the MRFF for breaker 204 had not occurred because the breaker would perform its design function to trip under an overload condition. The inspectors discussed with Energy the breaker function was to supply power to the safety-related loads, and this function would not be met under a breaker overload condition. So in other words, they say, don't worry, you're safe because the breaker will, if there's a surge or a short circuit, the equipment will be safe because the breaker, because the safety breaker will trip. But then they're saying, but you didn't consider that you're going to lose safety-related electrical loads and stuff like that. This is, it's just like they're playing with the NRC like a mouse. They're waiting for the NRC to interact. In other words, these guys know what's going on, but they're trying to feel how much the NRC inspectors know, and if they're testing how much they can get away with. It's really not a good sign. Further, following discussions between the inspectors and energy concerning incorrect MRFF, the corrective action for Pete was reviewed. A licensing engineer noted the opposite train had not been evaluated for possible overload conditions. How come? All right, they caught it on a simulator and they're working through this thing, but how come they didn't catch it before? Months, years before this. 40-year-old plant, and they're first catching a overload condition. Where is everybody? How come that? How come this is good? Well, they caught it. They caught a fault, an inaccuracy on how the system is configured or supposed to be configured, but how come all these processes that the energy and the NRC have didn't catch it much earlier? How come these processes failed? And everybody kind of forgets about that. So we go on. The inspector evaluated a modifications that was implemented in 1998 to provide a fuel oil transfer system from the station blackout procedure, diesel generator, underground storage tanks to the EDG underground storage tanks. The station blackout fuel oil transfer system was put in place when the license determined the on-site EDG fuel oil storage tank would not meet a it's the worst thing in the world. So that the EDG fuel oil storage tank wasn't big enough, so they're gonna, make it more. See, that's how they do it. And you save a couple of bucks, we'll drive up complexity. Instead of having the right amount of fuel in the right tank and it being really simple and stuff, now, the tank is half the design capacity, so then you got to hook up another system and more procedures, and like I said, you got to, if you had that kind of an attitude of always, when you have problems, you in order to save money, you drive complexity upwards instead of driving complexity downwards to being more simplified and easy for the the operators to deal with. If you've got a system that's 500,000 parts or 2 million parts, and I don't know how many, 800 employees, and all sorts of specialized skills and stuff like that, and the instinct of errors is to make more procedures and more laws and more processes and stuff like that, and more paperwork. Eventually, at some point, you're going to overload the system with complexity, and nobody's going to know what they're doing. It's going to be so complex, so self-generated complex, because you don't want to spend the money to make the system easy and functional. You're in problems. You got big problems. And remember, we got leakage in Hipsy or 6 Hipsy valve. We got leakage in heater drain pump, and now we got reactor cooler 6. Then they talk about, what was that? Surveillance testing. They got a reactor coolant system leakage somewhere and stuff like that. Leakage all over the goddamn place. And so then you say, well, why do you have a plant like Palisades that's got a reputation for its piss and leaks? Left and right causing shutdowns, and stuff like that, because you have an attitude that you accept leaks, and you wait till the last second and then you find a leak, and then you kind of make believe it's not risk significant, and you wait for months in order to fix it, and a loss of quality, and next thing you know, you're sitting there with a handful of leaks of all different. It's leaking like the Titanic and stuff, and so again, that's a problem. The best is yet to come. The best is yet to come. Implementation of the operability determination process. I mean, just look at this. Remember what's that other stuff? What? It's going to be worth it. It's going to be worth it. Sorry, I hate to doing this. Energy this is the root cause. This is the playing musical chairs where they're trying to start up business, and everybody trying to get out of the control room at the same time. Energy identified the root cause of the issue as the root cause of this event was a failure to adhere to established standards and expectations due to a lack of consistent supervisory and management oversight. One of the worst actions that Pilgrim ever happened. The root cause of this event was the failure to adhere to established standards and expectations due to a lack of consistent supervisory and management enforcement. So we get back down to this guy. Let's go back down to this guy. So the I forget how they would do it. CR report was written by the operations department discussing a trend in the rigor of initial operability determinations. As a result, the operations department focused on further attention on improving its skills set of senior reactor operators and operating determinations through the use of feedback process, periodic training, and what's it look like? Guide to operability, right? You hope that they learned something with all this business with the safety relief valve leakages and how you determine operability. So there's several condition reports over the last few years have been written to assess operability shortfalls and to address programmatic areas for improvement. And a lot of this stuff that's just gotten so complex, so complex that and so many equipment that's degraded, and it's just hard to manage. And so then we get down to operability. So and this is a repeated issue with what component was that? Emit steam to the HIPSI turbine. I don't believe it's. I believe it's something else. But anyways, the inspector identified a minor deficiency associated with Energy's evaluation and documentation of their efforts. In particular, the valve had similar issues in the past, 2007 and 2009. They do this stuff over and over again. If you're lucky, they document it, and then it's lost in their document system, and then it pops up again, over and over again. Like, remember I talked to you yesterday about a lot of these issues are issues that are repetitive in nature, and a minor infraction. So says the NRC, and non-cited violations, and you need not change your behavior. It's perfectly acceptable behavior, but we got to go through this bullshit process, paperwork process to make the public happy and stuff. Energy's extent of condition repeat issue reviewed for the 2011 problem did not clearly identify that the prior nut machining was not effective. There was still not sufficient stem to stem nut clearance and preventing repeated problems, right? The stem nut, then they blame it on not having is next to a steam hot system, and they got lubricant, and the lubricant is drying out, and it's causing the it's a poor design of the system. It's a poor design of the valve, and doing a half-ass with business with machining a nut is anybody that knows anything and why isn't everybody saying there's those kind of valves all through the industry? Is anybody else having these kind of problems? And is it only happening to Pilgrim plant and stuff like that? Is Pilgrim plant doesn't want to replace the valve and they're blaming it on lubrication drying out and stuff? That's a favorite pattern of the industry, to blame it on lubricating drying it out, and the NRC swallows it, and then the valve fails. In addition, the evaluation did not identify the prior information related to thrust issue with the operator. Could have provided insight into potentially degraded valve operator performance. Notwithstanding the incomplete documentation of this information, the inspectors found Energy took reasonable corrective actions for all contributing causes of this behavior, including extent and conditions. You know what? You don't have to have any broad change of behavior on this guy. You guys did fine. It broke 3 or 4 times, and you missed a whole bunch of stuff. But the system, they throw it through a system, and it doesn't change the behavior in energy. And so the NRC is saying, yeah, that's all right. You threw it through the system that it's going to fail. This corrective action system that's probably chock full of stuff, and they don't know what they're doing, and there's no evidence that the corrective corrective actions systems for energy works, but we'll throw it in the system and we'll make believe it disappears, and until it breaks again, and it happens over and over again, right? Then Fukushima's the stuff that they didn't do for Fukushima. They knew there was deficiencies and then didn't document it, and the NRC caught them with their pants down. Energy did not verify the accuracy of the design with respect to this station blackout battery as required by procedure. Weren't following the procedures. Had procedures all written out, but who follows the procedures at Pilgrim and stuff like that? So the battery, again, it's who's accepting this crap? The battery vendor did not provide data to accurately support a minimum battery voltage of 105 volts VDC. Safety battery, and they don't know the capacity at its low voltage. It's crazy stuff. And so, annual sample 2011 emergency diesel generator equipment reliability and adverse trends, right? I've been talking a lot. This guy's been talking a lot 2 months ago about station blackout, loops, and stuff like that. How it's been portrayed in the media that this loop it's worse than a loop. A loop, you could have a loop in a clear blue sky day, right? It's bad. But it's a whole lot worse if you have the same loop and we're in the middle of a blizzard and all the roads are clogged, and you don't have all the right people on site and stuff like that. So it's a loop squared. You know what I'm saying? The inspectors performed an in-depth review of Energy's evaluations and effectiveness of corrective actions associated with equipment or component failures on the emergency diesel generator. Specifically, Energy experienced 1 critical component failure on an A diesel generator and 4 on the B diesel generator in 2011. How they do in 2012? You know what I'm saying? They're reporting this now at the in January 1st, and they're talking. This is a famous tactic of the NRC. You know, oh, well, that's a year ago. That's 2011. It doesn't matter now. And so you know, all 2012. You'll be waiting until next year to find out what they're doing in 2012, right? And we're 2 months into 2013. So they're gonna, you know, effectiveness of corrective actions. Remember, I tell you the corrective action program with energy is a black hole, and it doesn't work. And over again, and all the NRC wants energy to do is throw it into a bureaucratic corrective action process. You know, they get into trouble if they throw it into a corrective action program. They're okay, right? No need to change in behaviors. You know, if you're spinning that paper around, if you're churning that paper around, and you're making it look, you got everybody covered paperwork wise, then everybody's happy. But if the accident happened and the public wasn't taken care of, you know, there's no worry about that. So, in-depth review of energy's evaluation and effectiveness of corrective actions associated with equipment or component failures on emergency diesel generators. Remember, emergency diesel generators. You just got done with a long loop during a blizzard, and you look at what these emergency diesel generators were doing in 2011. Specifically, Energy experienced 1 critical component failure on the A diesel generator and 4 on the B diesel generator during 2011. You notice how these inspection reports, they don't have any links to you know, they're probably not even written up and stuff. Normally they're not even written up. They're not even put in the public records and stuff like that. If they were, there's no way, you know, then you gotta, it's a lot of work to look up at all the 2011 stuff on the diesel generators and stuff, and a really narrow segment of the 1 or 5 people in the United States would probably have the wherewithal to go back and look and see what this is talking about. If it's recorded by the NRC, it certainly isn't recorded by in the public realm by Energy and stuff like that. So they had 5 failures, one on A diesel generators, 5 critical component failures on EDGA, and 4 on EDGB during 2004. It's a wonder those emergency diesel generators worked this last blizzard. It was written to document an adverse trend and determine actions to improve EDG system reliability. Well, where is it? You know, how do we know the depth of what's going on here, and how do we know the strategy Energy uses to improve the reliability? You know, where is the point? You say to yourself, these components here, you know, if they're mechanical or they're electrical, it's junk. It's time to replace. It's time to clean this crap out and get new stuff in there. How do we know? Or is this just going to go back to one at a time? Oh, component breaks, we fix it. Component breaks, we fix it. Component breaks, we fix it. Component breaks, we lose it in our corrective action process over and over again, you know, and stuff like that. And you don't really understand, you know, how they really are going to improve the EDG system reliability. The 5 EDG failures were documented separately by individual CRs at the time of each failure. The inspector assessed Energy's problem identification threshold. The inspectors address Energy's problem identification threshold, associated cause analysis and evaluation, extended condition reviews, and the prioritization and timeliness of the corrective action to determine whether they were appropriately identified, characterized, correcting problems associated with these, and whether the planned or completed corrective actions were completed. Razzmatazz, but they never explain what's going on with those important diesel generators. They never say, energy, you have to report that to the public, and the NRC never really reports on what's going on here and stuff like that. You're damn lucky those emergency diesel generators worked. And so, back to the reactivity LER. Energy identified the root cause of the issue as the root cause of this event was failure to adhere to established standards and expectations due to a lack of consistent supervisory and management enforcement. So here you go back to that. How is management enforcing with this repeated nature of after the reactivity accident? How are they changing? How has management gotten better? This isn't getting better. And it proves, if this 2011, the same year, I don't know when that it was May. It was May 2011 and stuff. But you see that the root cause, failure to adhere to established standards and expectations due to a lack of consistent supervisory and management enforcement. So Energy and the NRC fix this problem is associated with reactivity controls on startup, right? This won't happen for another decade, but there's the same shit spinning on around as far as the diesel generators and as far as management enforcing standards and being really aware of what's going on and changing behavior and not changing the behavior of the top organization along with the guys under them and stuff like that. Concluded the root cause evaluation was thoroughly appeared to identify the underlying causal factors. If they fix the underlying causal factors with the reactivity problem, right? Musical chairs during a startup, the diesel generator problem would have never shown. The repeated nature of all these critical failures with the diesel generator would have never happened, right? Right? So, again, these guys are just filling out paperwork, right? They're covering their asses by filling out paperwork and churning paperwork to make it look like they're doing their jobs. And you see it in the temporal or the when you read these papers, you think they're doing good, but if you don't have a context with it, if you have a context word of what's going on here, they're doing it over and over again, and all their corrective actions and the NRC slapping them on the side of the head is just insufficient to get them to do the right things and stuff like that. And they're walking into an accident. These guys are getting older, and they're losing people, knowledgeable people, and they're reducing quality and stuff like that. It's not a good sign. So diesel generators, you know what I'm saying? Diesel generators, the guys that saved them. If you didn't have the diesel generators, and they were running around doing procedures and operating equipments and never tested mode before, we'd all be pissing our pants if the diesel generators didn't work. And I think we're about done here. So how much time did I eat up? Will this be my longest one? I wonder. I'm Mike Mulligan. Thank you.